Declassified materials of the Armageddon's rehearsal. What did the USA and USSR nuclear explosions in space lead to? Nuclear weapons, probably the most terrible invention of mankind. From 1945 to 1996, more than 2,000 tests were carried out. For military purposes, nuclear bombs were used twice. Hiroshima and Nagasaki. The most powerful charge ever detonated was the Tsar bomb, 58.6 megatons. All this is well-known information, as well as the fact that nuclear tests were carried out on the ground and underground, in the ocean and in the atmosphere. Much less is known about explosions in space, though. On May 28, 1962, a rocket was launched at the Kapustin Yar missile range, which launched the Cosmos 5 satellite into a highly elliptic orbit. Officially, it was supposed to study the auroras, but in reality, its main task was to assess the consequences of the most powerful man-made nuclear explosion produced by mankind in space. We've already begun to forget about the nuclear dance, which was staged at the turn of the 1950s to 1960s by two superpowers, the USA and the USSR. Then, improving their weapon system, the main opponents in the global confrontation almost daily blew up nuclear and thermonuclear devices. Moreover, these tests were carried out in all natural spheres, in the atmosphere, underground, underwater, and even in space. It was only in 1963 that the USA, the USSR, and the UK signed an agreement banning nuclear weapons testing in the atmosphere, underwater, and in outer space to put an end to this madness. But by that time, humanity had already managed to do something. After a while, some of the materials on nuclear tests in space were declassified. Mastering the energy of the decay of the atomic nucleus, the appearance of nuclear bombs and reactors opened up unprecedented opportunities for designers. What science fiction writers dreamed about became reality. It was supposed to supply cars and tanks, ships and planes, launch vehicles and interplanetary ships with nuclear energy engines. The birth of the idea to test nuclear weapons in space was not long in coming. Experts believed that such explosions would not only provide unique scientific information, but would also serve as a kind of demonstration of power, showing the world, the whole world, that a great nuclear superpower, what a superpower is capable of doing. At the beginning of the 20th century, the founders of theoretical astronautics wrote that at the first stage of exploration of extraterrestrial space, it was necessary to produce a noticeable explosion on the moon. Terrestrial astronomers would have recorded the resulting flash and would have confirmed the historical priority of the state in reaching the surface of the nearest celestial body. In 1901, Robert Goddard discussed this idea in his early article, Movement in Space. He analyzed the possibility of launching a projectile to the moon using a huge cannon, and the payload was to be packed of magnesium powder, a flash of which on the shaded part of the moon could be seen through a telescope. The proposals of the founders were remembered when the formation of Soviet plans for the exploration of the moon began. In early 1958, the chief designer of the Special Design Bureau No. 1, Sergei Korolev, prepared a report on the basis of which a whole package of projects was formed. Among other things, the project of the Luna G apparatus was discussed, which later received the designation E4 in the working documentation. The device included special equipment with automation, a high-altitude detonation device, and explosive devices, which was intended to organize an explosion flash on the surface of the moon, which would make it possible to record the fact that a rocket hit the moon and determine the composition of lunar rocks using spectral analysis of hot gases formed during the explosion. The designer's initiative was supported by Mstislav Keldysh, who at that time headed the Scientific Research Institute No. 1 of the USSR Ministry of Aviation Industry. On January 28, 1958, Korolev and Keldysh sent a letter to the Central Committee of the CPSU in which they set out their vision of the prospects for studying the moon. Later, the E4 project was worked out in detail, and OKB-1 even made a model of the station. Its dimensions were set by physicists who proceeded from the parameters of the nuclear warheads that existed at the time. A container with a charge of 400 kilograms, like a sea mine, was studded with fuse pins to guarantee an explosion in any orientation of the station at the time of landing. However, things did not go beyond the layout. At the discussion stage, reasonable questions arose about the safety of such a launch. If the launch vehicle had crashed in the areas of work of the first or second stages, then the container with nuclear charge would have fallen on the territory of the Soviet Union. If the third stage had not worked, then the fall could have occurred on the territory of neighboring countries, which would have caused an international scandal. In the end, the E4 was abandoned. An elementary calculation put an end to the disputes, the results of which convincingly showed that the brightness and duration of a nuclear flash in the cosmic void at a distance of the moon would clearly not be enough for its reliable photo fixation from the Earth. A similar project under the code designation A119 was also worked out by the US scientists. It developed from the end of 1958 to the middle of 1959, was strictly classified, and in the documents passed under the neutral name Study of Exploratory Lunar Flights. At the Illinois Institute of Technology in Chicago, a group of 10 specialists led by nuclear physicist Leonard Raffel dealt with this issue. This group included such famous astronomers as Gerard Kuiper and Carl Sagan. Initially, the designers planned to use a thermonuclear bomb, but at that time there were no rockets capable of delivering such a payload to the moon. Therefore, it was decided to use a W-25 warhead, light and lower power, 1.7 kilotons. The automatic station with W-25 was supposed to be sent to the unlit side, the dark side of the moon. The dust cloud formed by the explosion would have risen to the considerable height, falling under the rays of the sun, due to which it could be seen from the Earth. But the project was stopped by customers without explanation. It's believed that the decision to close the project was facilitated by the leakage of classified information. Carl Sagan, who was engaged in the creation of a virtual model of a hypothetical nuclear mushroom in low gravity, acquainted his colleagues at the university with the results of his work. The prospect of using near-Earth space as a springboard for deploying strike weapons made us think about ways to deal with artificial satellites even before the appearance of the satellites themselves. The most radical means seemed to be the destruction of spacecraft by the explosion of a nuclear charge delivered by a rocket beyond the atmosphere. US scientists laid the foundation for experiments in this direction. In the summer of 1958, in an atmosphere of heightened secrecy, preparations began for the Argus operation. The organizers intended to study the influence of the damaging factors of a space nuclear explosion on terrestrial radars, communication systems, satellite and ballistic missile equipment. In addition, scientists were interested in the interaction of radioactive plutonium isotopes released during the explosion with the Earth's magnetic field. The US physicist Nicholas Christophilos put forward the hypothesis that a significant military effect from nuclear explosions in space can also be achieved as a result of creating artificial radiation belts similar to natural ones. The W-2 warhead selected for testing was a modified X-17A ballistic missile launched from the USS Norton Sound, AVM-1, which was part of the Task Force 88. The first nuclear explosion in space took place on August 27, 1958, at an altitude of 161 kilometers above the South Atlantic Ocean, 180,000 kilometers southwest of Cape Town. 3 days later, the second nuclear explosion was carried out at an altitude of 292 kilometers. The third explosion as part of Operation Argus was carried out on September 6 at an altitude of 750 kilometers. I wonder if this has anything to do with the problems of the Earth's magnetic field in the South Atlantic anomaly. Now, explosions in the framework of Operation Argus confirmed the hypothesis of Christophilus. Artificial radiation belts did indeed arise after these explosions. Artificial radiation belts from the nuclear material. Now, Soviet specialists also managed to obtain detailed information about the first space explosion. 3 geophysical missiles were launched from the Kapustin Yar test site. The measuring equipment installed on them recorded serious anomalies in the Earth's magnetic field. Again, is this having to do with the South Atlantic anomaly? So these things caused serious anomalies in the Earth's magnetic field. Subsequently, the data obtained were classified. The Soviet response to Operation Argus was a series of Soviet nuclear explosions called Operation K. The main task during the experiments was to test the effect of high-altitude nuclear explosions on the operation of radio-electronic means of missile attack detection and missile defense systems. Operation K was led by the State Commission, headed by General Alexander Gerasimov. Now, the first 2 experiments were carried out October 27, 1961, and the other 3 on October 22nd, 28th, and November 1st of 1962. In each of them, 2 R-12 ballistic missiles were subsequently launched from the Kapustin Yar missile range, and their warheads flew along the same trajectory at a certain distance from each other. The first missile was equipped with a nuclear charge, which was detonated at a given height, and numerous sensors were placed in the head of the second, designed to measure the parameters of the damaging effect of the resulting explosion. The height of the detonation of charges in the experiment was up to 300 kilometers, with a power up to 300 kilotons. U.S. nuclear tests in space were also not limited to Operation Argus. One of them took place in the summer of '62 as part of Operation Aquarium. It was planned to carry out an explosion of a W-49 charge with a capacity of 1.4 megatons at an altitude of about 400 kilometers, and this experiment was named Starfish. The first attempt to carry out a record explosion ended in failure. On June 20th, 1962, a Thor ballistic missile was launched from the site on Johnson Atoll in the Pacific Ocean, but at the 59th second there was a sudden shutdown of the engine. Later it turned out that the officer in charge of flight safety sent a team on board that initiated a self-destruct mechanism. The rocket was destroyed by conventional explosives at an altitude of 10 kilometers, and parts of the debris fell back on Johnston Atoll, the other in the vicinity of the island. The experiment was repeated July 9. The Thor rocket was again involved, and this time the testers were waiting for success. Eyewitnesses say that the W-49 explosion at space height looked incredibly colorful. A nuclear glow could be seen even in New Zealand, that is 7,000 kilometers south of Johnston. In the Hawaiian Islands, at a distance of 1,500 kilometers, an electromagnetic pulse knocked out 300 street lamps. Hopeless damage was also received by a poor range of consumer electronics at the time, including televisions and radios. Unlike the 1958 tests, the Starfish experiment quickly gained publicity. The explosion was observed by space facilities not only from the US, but also from the USSR. The Soviet satellite Cosmos 5, being 1,500 kilometers below the explosion horizon, registered an instantaneous increase in the intensity of gamma radiation by several orders of magnitude, followed by a decrease by 2 orders of magnitude in 100 seconds. After the explosion, an anomalously powerful radiation belt appeared in the Earth's magnetosphere. All satellites that entered it received damage in the form of rapid degradation of solar panels. The presence of an artificial radiation belt later had to be taken into account when planning the flights of the manned Soviet ship Vostok 3 and 4 in August of 62, and the US Mercury 8 in October of the same year. Serious pollution of the Earth's magnetosphere was noted for several years, and the explosion itself was included in the Guinness Book of Records as the most powerful nuclear explosion in space. In June 63, the United States came up with a proposal to conclude an agreement on a ban on nuclear explosions in the atmosphere, in space, and underwater. The Soviet leadership responded to this initiative. The corresponding agreements were signed in Moscow August 5, 63 by the foreign ministers of the USSR, the US, Great Britain, but alas, no one can say with 100% certainty that it will last forever. It's believed that by experimenting with nuclear explosions in space, scientists managed to obtain a lot of scientific information, including the very important one, radiation in space. We would like to hope, however, that in the future, knowledge of this kind will be obtained in some other way, if only because there are thousands of satellites in Earth orbit today, and their loss can lead to the most unpredictable consequences. So obviously their explosions in space caused radiation in space, and also anomalies in the Earth's magnetic field. I guess it was in the area, the South Atlantic anomaly. Who knows? Did it exacerbate it? Did it increase it? And we know that the Earth's magnetic field is also declining, and scientists don't know why. This is by Soul Ask on Collective Spark. Please leave your comments, and thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support, and that you find all my content so interesting. You'll find the Patreon account details in the description box